lectures throughout the western states and conducted several practical workshops ranging from 1 day to a week in length. He is certified as an instructor in the states of Oregon and Nevada, and he's a member of the International Association of Bloodstain Pattern Analysts. And so I'd like to introduce to you Mr. Gary Knowles.
I've also applied to the FBI Academy numerous times. And I'm also a member of the National Geographic Society thanks to my grandmother. Where's my multimedia man? There we go. Guess we have to turn out the lights, and any of you that want to move forward wouldn't hurt, so you can see. Otherwise, I usually stay in the back of the room myself also. I may have to have somebody focus the slides unless this is an autofocus. I don't know. Some of the slides tend to be out of focus once in a while. A little more about myself. I have been with the Oregon State Police for 20 years. I started out as what they call a traffic jockey. I chased taillights. And that was okay for about a year. I guess all of us at one point or another want to be a fireman or a policeman. So I became a policeman because I needed a job. I came from Ohio originally and wanted to go into fisheries and wildlife, and everybody and his brother was already one of those, along with oceanography. And the corporal at the town I was located at said they were looking for college-educated people for the department, particularly in game enforcement. I do have a degree in zoology. So I joined and went to talk to the deputy superintendent and said, hey, I've never hunted or fished. I don't think I'd make a very good game officer, so they stuck me in traffic, which was okay for about a year. I always liked to chase the speeders. But I didn't like picking up drunks. I picked up my fair share, but I don't like being around drunk people unless I'm drunk too. Unless you're drunk with them, they don't make any sense. And when you're drunk, they make perfect sense. Or else I'm not listening. That's probably it too. But I did that for about 3.5 years, being a cop. And it wasn't until the state lab director died and the superintendent died that they finally called me up and said, well, how soon can you be in Portland at the crime lab? And I said, is yesterday too soon? My corporal, who was in charge of me, was on vacation, and at the time I got the call, and I was gone before he got back, so I really wanted to be in the crime lab. I went to recruit school, didn't know what a crime lab was, and here's this guy showing all these cut-up dead bodies and blood and everything else, and I thought, hey, I could do that. I'd like to do that. So I finally, after 3.5 years, got into the Portland Crime Lab. Other than that, basically I'm stationed out in the Medford Lab right now. I'm currently the lab director there, and I supervise 8 people there. And like all other states, we have our budget problems. We're looking at the potential of losing people, so you might get some applications from the Oregon system if we haven't already gotten some from California and some of the other states as well. As far as Bloodspatter is concerned, I haven't really had much formal training itself. I kind of took the bull by the horn and did a lot of experimentations along with Jim Pex, and attended numerous homicides and worked with those homicides. If there's one thing that you can get out of this lecture today, is that if you have the opportunity to go to the crime scenes themselves, be sure that you take the opportunity to examine the blood patterns that are there, because the real life situations or real death situations are much better than what you can do in the laboratory as far as duplicating what actually goes on during these crime scenes. How many people here are not forensic scientists, are not criminalists? Okay, we have a few. Do we have any attorneys? district attorneys count as attorneys also. Okay, wow, you're just lying if you're out there. Not that I have any attorney jokes or anything like that. But it was kind of interesting. I too would like to thank Margaret for asking me to come down and speak. On the way down here, I was staying in Sacramento for the evening, and we were sitting in the hot tub, and there was a rather inebriated group of gentlemen in the hot tub with us, and they were talking about politics, and this one kid that was rather drunk said, well, says, I don't think I'm going to vote for anybody. First of all, I don't know how many people are even running for president. He says, I don't like Bush because he hasn't done anything for us, and I just don't feel that I can trust Clinton. As far as Perot is concerned, I just don't feel right about voting for somebody who looks like Yoda. So, good points all, right? Many of you have probably looked at or have studied or heard a lot about pattern or Bloodspatter interpretation. It's been hyped up over the last few years by some individuals, and I'm not here to say that it's an end-all or a cure-all to homicide scene investigations and reconstruction. I offer it, as I do in all my lectures, as simply another tool that forensic scientists use in trying to reconstruct a crime scene, and that's basically what we're trying to do by the investigation by the detectives, by the investigation and analysis done by the crime labs, and by putting the case together on the part of the district attorney. This tool, and of course I'm going to show you the good cases, because most of the detectives in my area know the ones where I've screwed up, and I certainly don't want to show the ones where I've screwed up. But we'll show individual cases as well as some of the laboratory experiments that help the science of Bloodspatter interpretation help reconstruct the crime scene for a jury or for a judge. There are several things that can be said about Bloodspatter. It is not strictly a subjective type of analysis. There are some objective types of things to it. Some of the questions that Herb McDonald, who back in the early 70s did some studies with Bloodspatter interpretation, has cited is that you can tell the position of individuals when they are shedding the blood. In other words, were they standing up, sitting down, lying down? What were their movements after they've shed that blood? We can tell where an individual, the perpetrator, the suspect, was standing when he was causing the injury. Now these are under all ideal conditions. We can tell his movements. I've had cases where I've been able to tell that he held the weapon in his right hand or his left hand, depending upon the circumstances of the scene. We can tell the direction of travel that he may have left with the bloody object, etc. So there are a lot of positive things, objective things that can be said in Bloodspatter interpretation, and hopefully we can point some of those out and tell you how we do it. Do we have many people here that have experience in blood pattern interpretation? Yikes. Well, this is my day, so if I say something wrong, just tell me later. Don't try not to embarrass me, Jim. I think we've all, any of us that do get to go into the crime scenes, go into a crime scene like such as this one here, and you wonder, well, what can we really tell an investigator? Can we really help the cops in reconstructing this crime scene? And I think one of the things that all of the crime scene technicians or criminalists that go out to the scenes have to fight is the rush that detectives put on us. They want us to hurry up and get out of there, because chances are they've been there quite a while. They've had to work with search warrants, get affidavits for the search warrants. They've had to begin their interviews, and then they have to call us, and they have to wait for us to arrive at the crime scene. So consequently, there's a tendency for investigators to try and push us. I think some of the best investigators investigations that are done as far as a crime scene technician is concerned is when they take the time to sit down and just use their head and think. And we frequently take more than one person to a crime scene from the crime lab in our area, and that helps to have somebody else at the scene to kind of help push our own mental capabilities. Talked a little bit about blood. Basically, blood spatter interpretation or blood pattern interpretation is really just a study in fluid dynamics. We have basic fluid physics that is applicable not only to blood, but it's also applicable to other liquids. I've done vomit spatter patterns. I've done wine spatter patterns. And I've also done some mud spatter patterns, and I have a case of mud spatter that I'll show you later in the morning. And basically those that have not had any familiarity with blood pattern interpretation, when you get out of the shower or if you look at vehicles that have mud on the side after this presentation, maybe you'll think about the blood spatter interpretation program you saw today when you are identifying the angles of the mud or of the water. This was my only successful attempt at high-speed photography. After about 13 frames, I was able to catch a drop of blood more or less in mid-flight, kind of streak. Some of the basic premises of the flight of blood through the air depends upon its specific gravity, its cohesiveness, its surface tension, and the way it falls. Herb McDonald, in his book on bloodstain interpretation, had determined that the maximum velocity of a naturally falling drop of blood is 25.1 feet per second. Anything above that is considered to be a projected blood droplet. And he also points out, and some of the experiments that we've done also shows that the blood does not break up into smaller droplets as it goes through the air unless it is projected through the air. Just a falling drop of blood will not break up into several parts. It has to strike a surface, and even then, as you'll see later, the surface has to be fairly porous. One of the misconceptions of laymen, at least, of a falling drop of blood or any fluid is that it has a teardrop shape like the cartoons show, and that's not true. There's an article on the shape of raindrops that we found, and this is generally the shape of the falling liquid. It's rather hamburger shaped with the pressure against the air molecules flattening it out towards the bottom. But it's not the side profile that we're interested in anyway in regards to the backdoor man. In regards to our interpretations and to the study of the blood spatter, it's the fact that as it's going through the air, as you're facing the blood droplet, it's a perfect sphere, or at least it's circular, if not a perfect sphere. As far as calculations are concerned, in theory, it is considered, for practical purposes, a perfect sphere. Some of the tests that are performed, and we'll do some of that today. Incidentally, I understand there was about 4 or 5 people that were interested in attending the workshop this afternoon that are not signed up for it. I think we can squeeze those 4 or 5 people in, so if you just show up at our workshop this afternoon, those of you who were not able to sign up, I think we can get you in. You will lose 25 points on the test, however. This test here that we're doing is just examining the shape of the blood stain after a blood droplet has fallen after a certain distance, and anybody that's done any experimenting in blood droplets has probably done this thing. I don't find it of a great deal of value. The idea of it being looks like my slides are a little crooked, is to examine the effect of distance on the shape and size of the blood stain. As you can see, that after about, maybe 11 or 12, 13 inches, there isn't really much difference. Some of the literature cites that up to 4 feet you can detect a difference. As far as the real world is concerned and your crime scenes, if you have a blood stain, you're not going to be able to interpret its distance as far as how far it fell, because you don't know what the volume of that blood stain was. Normally, the volume of a blood stain is said to be about 0.05 milliliters. In other words, it takes about 20 drops of blood or any liquid to make a milliliter of fluid. So this is something we do. One of the things that could be examined is the density of the blood, how dark the blood stain is. That may have some value up to about 6 inches. But as the experiments show, that it doesn't have a lot of value. Surface does. What really got me interested in blood pattern interpretation is when Herb McConnell did come out to a case of ours in Tillamook, Oregon on a homicide investigation. And if any of you have ever heard him testify, he's fairly impressive as far as a speaker is concerned. And one of the things he did, and perhaps there's a little showman in him as well as a little bit in all of us, he gets up on a step ladder after having his own blood drawn within about 2 minutes. He gets up on a step ladder and stands up at about a height of about 8 feet and drops blood onto the glass surface, or a hard, smooth surface. And what he's trying to do is show that no matter what the height of the blood droplet falls, because of surface tension, you have that need for, or the desire of the blood droplet to hold unto itself the surface tension. Unless there's something to break up that surface tension, it's going to maintain a unspattered or unbroken blood stain, the ones on the glass slide. So he does this right in the courtroom, and as soon as he dropped it, just about everybody in the jury box gets up and they all look, because he gets them all psyched up for this. But the idea, really, it has very little to do with the case. But one thing it does do is help the layman to understand that they may have some preconceived notions about the science or about what you might expect is not always true. That's why we do experiments. And I think that was pretty impressive to me, that I was surprised that the blood droplet wouldn't break up when it hit a hard, smooth surface. Naturally, once you introduce porosity, as he mentions, or some protuberances, that breaks the surface tension and breaks it up into satellites. Some of the other surfaces, I brought along some different surfaces for the workshop that we can look at. It is important, though, when you are trying to interpret the blood stains, that you understand the nature of the surface you're working with. And also, there can be some confusion, I've seen it many times, with the secondary spatters. Those are the droplets that come from the original pattern as smaller droplets. And some people that have heard lectures such as this, some of the investigators, a little knowledge can be dangerous, and they tend to call those high velocity blood stains if they're any smaller than the blood droplet. And we had one guy that had been shot by our SWAT team and had dripped blood back into the residence and had lots of little satellite droplets where he had blood falling into blood. And they thought he had been shot numerous times. That's what the investigator was trying to say. If he had been shot numerous times, that the blood stains were not, the satellite blood stains were not a product of the actual shooting. It was just the blood dripping onto the porch. Directionality. This is where we are able to do the reconstruction. It takes a little experience and also some other calculations to put the whole thing together. But as far as the basic premise of blood pattern interpretation is probably directionality is probably the most important thing. What we have here is our little exclamation point in the middle of the slide representing a directional blood stain. And what we have is the blood stain originates from the top of the slide, the direction of the top of the slide. Each one of these blood stains is like little arrows. And again, forgive me, those of you who are trained Bloodspatter interpreters. I know you've been through all this, and this is rather boring to you. But we'll get on to some other things later. Let me fill in the ones that are less experienced. The shape of the blood droplet is sometimes called as a tadpole shape. The little drop on the end of some of those blood stains is caused by a wave-like action that occurs as the blood droplet strikes the target surface, and it's like the crest of a wave. It kind of flips over and dots the exclamation point. This doesn't always occur, usually only at the angles of about 20 degrees or less. And as I said, the direction of this blood stain is pointing from the top of the screen, which is where the blood stain came from. This is not what actually occurs as far as the action of the blood stain as it strikes the object. If you ever had the opportunity or have had the opportunity to see some high-speed video of blood stains being created, Ed Shipp and Jerry Chisholm have had the opportunity to work with Kodak on high-speed video, and they show some very interesting things that are occurring to the blood stains as they go through the air and as they strike objects. I think that's a tremendous tool that I would feel really glad to have the opportunity to work with. We tried to do that in Reno last spring when we had our Northwest Association meeting, and unfortunately the camera was not available, but we did see some of the films that Jerry Chisholm and Ed Shipp had put together. What this is doing is kind of showing, theoretically, when you got the blood stain coming through, if you want to make an interpretation on the angle by using trigonometry, you should have a perfect ovoid shape. In other words, it would be as if the blood stain were to travel right through the surface and leave a perfect ovoid shape. And obviously it doesn't do that. It gives that tadpole shape. And what some of the films are showing is that even as the blood stain is striking the object, it's leaving a blood stain, so consequently it begins to lose volume and causes that irregular ovoid shape. Then with the little knowledge that has already been imparted, we can see now that with this slide, the majority of these blood stains come from the upper right-hand corner of the slide. This was a curious pattern that I developed. I was trying to simulate in a laboratory situation, or somewhat laboratory situation. I had an indoor firing range at the Portland Police Bureau, and I had lined all the walls, ceilings, and floors with butcher paper. This thing's like 60 feet long and probably 10 feet wide. So it took a lot of butcher paper, and I mounted a plastic bag about 6 feet above the ground, filled it with bloody sponges, and shot it with a 20 gauge shotgun slug, and struck it. You know, I was trying to simulate somebody getting shot in the head, you know, because it's so hard to get volunteers for these things. You have to use plastic bags. When the slug hit the plastic bag, it came off my little string and goes flipping down the firing range, leaving a quite an interesting pattern. That's why they don't all necessarily come from exactly the same direction. But it's amazing the different types of experiments you come up with. And you do this even as you're investigating the crime scenes, because you come up with so many different situations that you cannot foresee. And of course you come up with different scenarios that the suspect comes up with. And you try to duplicate what you think happened, what he thinks happened, or what the investigators think has happened. And to come up with various laboratory experiments to try to duplicate this, you can come up with some fairly unique things. Okay, once we've determined the idea of directionality, we can look at our crime scene and begin to develop a pattern. We look at as many of the blood stains as we can, or at least beginning with several dozen. And you can use string, you can use chalk. In this case, we've used color string, and begin to find out which direction these blood stains are coming from. Now, this is only on a two-dimensional plane. At this point, we are not interested in the third dimension as far as height is concerned. All we are seeing here is that all of these little blood stains are little arrows pointing in a direction. Of course, that directionality can go on out to infinity. As we do more and more of these blood stains, they begin to come together and converge to what are called points of origin. And the point of origin being is where did the blood begin to shed? In other words, where is the wound is generally what we're looking for, although it can also come off of a weapon that's being maneuvered, or a bloody hand or something like that. This was a mock-up of a case that we had in Tillamook where the ex-wife of our suspect had been shot, we assumed. What we got was a phone call from the defendant's attorney saying that my client has come to me and said that he has killed his wife in this unfinished cabin along the Wilson River near Tillamook. And that's all he was obliged to tell us. So we go out to the crime scene, plywood floors, and we find bloodspatter, blood stain all over this plywood floor. And this was before we had much experience with this. We took the plywood and we sent it back to Bert McDonald, and he was able to identify at least 3 different origins of high velocity blood stain, which I'll describe what that is later. And none of them were over 6 inches to 9 inches above the floor. So what we had here was a simulation where we had a crime scene where a person had been shot at least 3 times in a position that was approximately 6 inches above the floor. Now, some of the studies that have shown that generally, if you have clothing on, you're not going to get much, if any, blood spatter coming out through the clothing. So we assumed at this point that we had an exposed area of this individual. We hadn't recovered the body at this time. Could have been shot in the foot. She could have been barefoot. She also could have been naked and shot, or perhaps she was shot in the head on the floor. Well, about two months later, the body is found, and it's in the middle of summer. She's wrapped in black plastic visqueen for about 2 months in 100-degree weather, and unfortunately I was on another homicide trial, so I was unable to help recover the body. But as they were pouring the body into other plastic bags, one of my other cohorts, Mike Howard, who now runs the Bend Crime Lab, said that he was trying to lift the body up the side of the hill and it kind of fell against him, so he got all that goo on him. I said I couldn't think of a nicer guy that deserved it. So anyway, we've got a converging of lines and we got a point of origin. In that case, what had happened is he'd gone back to Iowa and called his attorney and said that yes, he'd done this deed. And so we had our trial that when we recovered the body, we found that she had actually been shot 8 times. And we kind of figured that too, because we actually found 822 casings. So that helped with the high speed or high velocity blood spatter too. But we also found out that 3 of the wounds, remember I told you that 3 of them were in exposed areas. We had 5 shots in her sweatshirt and 3 of them in her neck area. And so we were able to show that the high velocity blood spatter into her neck was while she was laying down on the ground, on the floor. He was convicted of manslaughter, and the case was appealed. And the reason it was appealed is that when he went into the police station in Iowa, after he had been given his Miranda warnings, one of the cops comes in with a cup of coffee and says, how's things going? How's your family? Are you having any problems? And this guy says, not anymore. And so apparently that got into the first trial. I didn't hear it, but apparently it did. And they were going to schedule a retrial, but I guess they decided that since he had already served 9 months, there wasn't any point in going any further because he spent probably most of the time that he would have spent in the pen anyway. I guess she was real nasty too, though. From all stories, it sounded like she almost had it coming. She was real witchy. Maybe that's why they felt sorry for him. Even if objects are moved in a crime scene, perhaps a book or a check, a gun or something that is initially there when the pattern is developed, when the gunshot, the bludgeoning, or whatever is done, we can also figure out where those objects were in the crime scene, and just simply by jigsaw fitting our pattern into our original pattern, we can determine where that object was. Plus, it also helps that there's a little square area where there isn't any blood spatter. That helps a lot, along with those 22 casings. Some of the other experiments that we do, this is important for the new bloodstain interpreters to understand, is to develop a series of cards, or at least examine a series of cards that are dropped at different angles. And this is what we do. We simply set up the different target surfaces at the different angles, and they try to hit those targets. Now, these are nice big 8.5 by 11 sheets of paper. In Jim and my workshop, we use 3x5 cards, so it makes it real interesting. It's not so bad at the 90, 80, and 70 degree angles, but when you get to the 10 degree angle, you don't have a lot of surface that you're looking down on. And of course, part of the grade is being able to hit the 10 degree angle without missing. Just showing the angles. You can see how little surface there is to hit on the 10 degree angle. Anyway, it's found, of course, that as the blood droplet comes down at a perfect 90 degree angle or straight down, it leaves a perfectly circular blood stain. It's as wide as it is long. And that tells us that the angle at impact is 90 degrees. As the angle becomes more acute, the blood droplet becomes more linear, or becomes longer, more ovoid. So at 90, 80, and 70 degrees, at 70 degrees you can pretty well tell that you've got an angle there. At 80 degrees, it's somewhat questionable. Now, one of the things we do caution our students and other interpreters is that when you're looking at blood stains that are a 1/16 of an inch in diameter or less, it is not a good idea to attempt to do angle determinations with those small of blood stains. Understanding, of course, that you can get magnifying glasses and measuring eyepieces, that you could actually make measurements on minute blood stains. The problem being with those small blood stains is you've got the effect of target surface, even on some glass. The object is, the blood is just too small to give you accurate angle determinations, and that's been shown through experimentation that it's very difficult. So you want bigger droplets to work with. 60, 50, 40. Of course, if you work with these for a period of time, you can do a rough guess on what the angle is. But even, I've done a lot of these, Jim's done a lot of these. We don't like to do that. Maybe just as a preliminary idea of what we're working with, we can do estimates on what the angles are, but it's always a good idea to either use examples. I always measure a dozen or so of the blood droplets and do a calculation that I'll show you to determine what the angles are. And of course, the 30, 20, and 10 degrees. Also, it's important that if you have the very acute angles like 20 and 10 degree angles, that you use those for directionality. Because as you can see, directionality is somewhat difficult at the higher angles. It's not quite as accurate as opposed to the 10-degree angle, which gives you a nice arrow pointing from where it came from. And again, the extra little drip at the end is caused by the wave-like action. Now you can also notice too that the blood stain, especially on the 20-degree angle there, the one on the 10-degree angle actually fell off beyond the size of that card. The blood stain looks like it's coming from down below. And so it's important here that you realize and recognize that that blood stain, that streak below the 20 degrees, is just an artifact of the original drop and is not another blood stain from another direction. And anytime we do any interpretations of crime scenes, we want to make sure that we are not doing an interpretation on any one blood stain. We look at the patterns. That's what it's called. It's called pattern interpretation. And it's not just a pattern of one individual blood stain, it's a pattern of the whole. This slide's upside down because it's to understand that no matter what angle your target surface is on, whether it's a ceiling or whether it's a wall, floor, whatever, at the moment of impact, at the time it hits that target, that whatever angle you come up with, that is a reflection of what the actual angle was at that moment when it struck the target. Now, understanding, of course, you can get arcing. If somebody's getting beaten on the top of the head, you get gravity affecting, and maybe you'll get a 10-degree angle on the ceiling. That doesn't mean that it originated 10 degrees from that spot. That just means that at that angle, at that moment when the blood droplet struck the surface, that was 10-degree angle. It may not be of any value on a three-dimensional plane, but it can still give you directionality as where in the room was the individual standing when they were beaten. Most of you that are familiar with blood stain interpretation know these formulas, theta being the angle. To determine the angle of any blood droplet, it's the arc sine or the inverse sine of the width of that blood stain over the length of the blood stain. And those can be measured with the little micrometer eyepieces, the little Bosch and Long eyeglasses that have scales. And whether you're using millimeters or inches, it makes no difference as long as you use the same units of measure. Now the formula below is the height. Here's where we get into the three dimensions. Once we have determined where in the room we have our point of origin, now we want to know how high did it come from. So if we have a body, which we generally do, even if it's 2 months later, we know that from the autopsy that perhaps the person was shot between the eyes. We can determine the height of the blood spatter by the distance, and I have some further diagrams to help explain this. You take one blood stain and measure the distance to the point of origin, which you have determined from your converging lines, measure that out to that one drop, and take the tangent of the angle of that one drop. When you do this formula several times, you can come up with an identifying height. I think at this point, before I fall asleep, why don't we take a short 10-minute break, have some coffee, stretch, get up, wake up a little bit, and at 10 o'clock we'll have another break where you'll go into the vendors and chat with them and try to win some prizes. These can be gotten out of various scientific supply companies. Edmund Scientific has these. Also, I believe Lightning Powder Company has these, and VWR and some of the others may also have these things that are pretty much essential for anybody that's doing any kind of blood stain interpretations legitimately. We actually measure the width and length, and here's what we're doing is we're measuring the width of the blood stain, simply going across the widest portion of the blood stain. Then measuring its length. Now, when we measure the length, as you can see, this one's got a little tail on it. We have to do somewhat of an estimation as to where the blood droplet, the would end up if it wasn't for the tail. So I just kind of bring it around approximately right here. You will find that if you experiment with these things, and we're going to do that a little bit this afternoon, we're going to actually do some dropping at angles so we know what the angle is, and then we're going to compare it to the mathematical calculation to see how far off it is. And you'll find that if you're a few millimeters off, or in this case, I think these are in thousandths of an inch, that it really is not that important as far as being off is concerned. Whether you're 26 degrees or whether it's 28 degrees makes a little difference to the overall crime scene interpretation. Basically, some of the math involved, the width being basically the width of the droplet as it falls through the air. The length is the hypotenuse of the angle. So, by measuring our blood spatter, we can substitute some numbers in here as an example. For instance, in our hypothetical blood stain here, it's 20 units across by 45 units long. And you can do it by either by calculator, or you can also do it just longhand. Basically, the 20 over the 45, and that comes out to 0.444, and actually keeps on going, 44444. Then, if you don't have a calculator, you can use the handbook of chemistry and physics. It's about 4 or 5 inches thick. Might be a little difficult to see. You look up the number under the sign column that comes closest to your answer. In this case, it was 444, 0.444. And at the top of the page, we see that 0.444 comes out to 26 degrees. Now, we don't care how many seconds and minutes and things like that, because, like I say, when we're working with crime scenes, it's not that critical. And so the answer, of course, comes out in tenths of a degree, or you can do the conversion. I find it just easier to use a scientific calculator and hit the inverse sign and number key, and then multiply that times your width over your length. In determining how high the origin was, your third dimension, in other words, okay, we know that we have an angle of blood stain. In this case, it's 40 degrees, not 26. We've changed numbers here. We have one blood stain that we're looking at. And we know that that one, by calculation or by comparing it to cards, however you determine it, you know that that's about approximately a 40-degree angle. You also know where your point of origin is, because you have all the converging lines that come together from all these little arrows pointing to where it was. So you have one point that you know, and you have another point that you know, which in this case is the 40-degree angle droplet. Measure that distance from the droplet to your point of origin. And in this particular case, it happens to be 7 feet. So we have a blood droplet that's 7 feet out, it's 40-degree angle, and simply by using the tangent of the angle, the tangent of 40 degrees, in this case is 0.83910, times the distance, 7 feet, that gives us an answer that your theoretical height is 5.9 feet, in tenths of a foot. So if we have a body with a bullet hole between the eyes, we know that this guy, if he was about 6'2" or whatever, was probably standing up when he shed that blood droplet. Now, of course, you're going to take more than just that one droplet to make your determination. You're going to do it with that blood droplet. You're going to find another one that's perhaps 10 feet out, or another one that's perhaps only 5 feet out, and you're going to get a range that's probably, depending upon the velocity of the blood stain, if it was a high velocity one, which means they go out pretty fast, you're probably going to find that you're going to be within a 6-inch area as to where this bullet hole was. And it might tend to be a little low, actually. But that's going to answer the question for the investigators and for the prosecutor: was the guy standing up, sitting down, or lying down when he got the shot? And if you're off by 10 degrees, so what? I mean, it makes very little difference. There may be a few cases that might be important. So here in our Tillamook scene, we took, of course, these are grossly exaggerated distances. In the actual scene where we determined there were 3 points of origin, they were only about an inch apart, the origins were, and you can determine those origins quite closely, even if they're within an inch of each other, because at some point you're going to have some bloodstains crossing the lines of the others. These are probably a foot apart. It's kind of a display board that I made up. It folds out and the little circus tent comes up and everything else there too. But I actually take this in, I have taken it into homicide trials to do the dog and pony act with the jury. And as most of us know, as all the crime lab people know, that unless the jury or the judge understands what the heck we're talking about, they are not going to pay attention to what we say because they may not understand it. And usually we have something to say. In fact, sometimes the crime lab actually has some real important stuff to say, and it may even contradict what the cops are saying or what witnesses and eyewitnesses are saying. And we know the experience that people would see one thing and may not remember exactly what they saw, or they may misinterpret what they saw. And of course, it's our job as criminalists to take the scientific facts and bring them together and show that, these are hard facts. I don't care what they said they saw. This is what happened. And so the little dog and pony show, for 10, 15 minutes on just almost any subject. DNA is a little different. It might take only 2 or 3 minutes to explain that. But for whether it's footprints, hairs, fibers, blood typing, whatever, a little dog and pony show, or at least an explanation of what we're doing, of course, helps the jury to understand what we're doing. The problem arises is when we get the defense experts and the prosecution experts together, and they're each talking scientific jargon, and then the jury tends to ignore both of them, unless you're really good, and then they'll turn and say, well, we don't care what the crime lab says, what do the cops have to say? And maybe the cops don't really have enough because it is a scientific case. So, a little showmanship, may not necessarily be scientific, but in a way it kind of is, because it helps get your point across. So here we have our theoretical scene. The point here is that you don't just use one blood stain to make your interpretation of the crime scene. Here we have our person who was shot between the eyes because he's standing up or sitting down. We have a 50-degree angle on the table. Well, he probably wasn't sitting down because there isn't any chair there. Also, he probably wasn't much of an assailant. The defendant can't really claim self-defense because the guy doesn't have any arms. So he probably wasn't attacking him. And he probably wouldn't make a very good rape suspect either. What? Anyway, the point being that you take numerous blood stains, again, not just a few, and try to converge as to where the individual was standing up to determine. You have to have that second point to determine your height, to use that formula. You don't have to use the formula. Like I say, if you can make cards that show the 10, 20, 30, 40, 50 degree angles, and you simply compare those at the scene, you take those to the scene, well, that looks like it's about a 20-degree angle. That will probably answer most of the questions. But as a scientist, I like to do about at least a dozen for each area with the calculator. This chart just kind of shows the error factors that you have to be careful of when you're interpreting these angles, even if you do a mathematical calculation. The problem being, and I don't know if you can raise that up a little bit more to see the bottom chart. If you get to like an 80-degree angle, if you're off by 10 degrees on an 80-degree angle, it may mean the difference, or a 70-degree angle, it may mean the difference between it may mean the difference. That's good. Put it down. A little too much coffee? The point being, if you make an error of, if you call an 80-degree angle a 70-degree angle, you may get half the distance. In other words, because it's so hard to measure the difference between an 80 and a 70-degree angle because they're almost perfectly round. You can have a wide range of height determinations if you do several of these. However, if you use the ones that are the acute angles, the 10 and the 20-degree angles, your error factor goes down. And if you're off by 2 or 3 inches at a crime scene and you know the guy was shot between the eyes, who cares if it was 2 inches or 4 inches or whatever, if it was 6 inches or 8 inches? I mean, you're answering the question, the guy must have been on the ground or darn close to the ground to have gotten shot between the eyes to have such a low angle of determination. So here again, I like those acute angles, those long blood stains will give you the best information and the most accurate and the goodest. Okay, talking a little bit about the characteristics of blood stains in regards to velocity of impact. And now, most of us are familiar with the terms high velocity blood spatter, medium velocity spatter, and low velocity. The terminology should be changed and is tending to be changed, but we still tend to fall back on what we know. The terminology should be high velocity impact and medium velocity impact and low velocity impact. And I'll go on to explain that a little better. This is what we call high velocity. And I may, from habit, refer to these as high velocity, low velocity, and medium velocity. This is a laboratory setup where I had a bloody sponge suspended approximately 3 inches above the 5x7 sheet of cardboard. It was centered in the cardboard. And I shot it with a 22 from the right side there. That's what the little arrow indicates, the direction of the bullet. And what happens is it created what we call high energy impact or high velocity impact blood spatter pattern. What we are interested in interpreting these is the number, the preponderance of the microscopic blood stains, an aerosol effect, as if somebody were to take a spray can of paint and spray it, a mist. That's kind of out of focus, I think. I don't know if you do any better with that. Maybe the slide's out of focus. That's a little better. Sure, we get some larger droplets in there. And one of the things that we saw when we were looking at the high-speed video is that when bullets were fired into the bloody sponges, we got a convergence of a grouping of blood droplets in the air. They tended to come together and create larger droplets. So the fact that you have a large droplet does not mean that it's a low velocity or medium velocity. You can have a large high velocity or high energy impact blood stain as opposed to an aerosol. But what we are interested in, and going into a crime scene, Jim and I have both been able to go into a crime scene before you even saw the body. You're able to tell that we have, and usually the body's not there because they called it off. We can tell that we have a gunshot type of wound. And it's by the preponderance of that aerosol blood spatter. This is the mist you see in between the larger droplets. Those are very difficult to recreate other than with firearms. With some high velocity fans, which doesn't occur very often at crime scenes. The only time I've seen anybody chewed up by a high-speed fan was in the James Bond movie where the guy's skiing down the slope and runs into the snow blower on the train. That probably created some high-velocity blood spatter. But bludgeonings do not create a preponderance, even though they can make some very tiny blood droplets. They do not create the aerosol effect that you see with firearms. We were able to duplicate some high-velocity blood spatter using an axe on a bloody sponge. And here it's the high energy of that focused energy at the end of an axe hitting the blood spatter. Also notice on this, what's really interesting in this is the backspatter. Notice that about a third of the blood stains go back in the direction of the firearm. This is what we're looking for when we get the suspect's clothing. And when you see the Diane Downs case tomorrow night with Jim, some of the critical information in that case was the high velocity backspatter that came back onto clothing. And that puts that person in proximity with the shooting. That's just plexiglass. That came out of, I think that came out of Saperstein, if I'm not mistaken. But anyway, the point being, of course, that you do get backspatter. I usually go on to explain to police officers that this is what happens when you break a window, and when you get a suspect that may be suspected of breaking a window, make sure you check their clothing and their hair for glass and things like that. With heads, it's great. As far as high energy impact, you've got an enclosed case of blood, and when a bullet strikes it, and many of us that have been to suicides know what can happen to a head on contact. It literally explodes, and they can fill this room practically with blood on all the surfaces. But you get that energy going into an enclosed skull full of blood, you will tend to get a lot of high velocity backspatter on hands. And suicides, this is great. This is great information, better than GSR kits as far as I'm concerned, for determining whether you've got a potential suicide or not. Looking, and I've got some pictures of that I'll show you later, looking at the angles to see if it's consistent with the individual holding a firearm and the backspatter coming on to the knuckles in a situation as if he was holding a gun. There's Matilda. It's one of our first attempts at experimentation. Of course, you try to recreate it as accurately as possible. Of course, most people don't have bald heads, but anyway, this one did. We stuffed her full of bloody sponges. This is just as the shot is being fired. You can see the styrofoam skin floating through the air. This is our happy hunter showing the pattern afterwards. This was an interesting person, the criminalist. About 7 years ago, he took over my job as the assistant director up in the Portland Crime Laboratory, and they were having trouble finding some of the cocaine cases that were needed on a rush basis. And it turns out that Steve had his secret stash of cocaine cases. He, I guess, gave a new meaning to the term consumed in analysis. In looking for these cases, one of the secretaries opened the drawer and found all these paper folds from all these cases in his drawer, and he had actually been stealing cases and freebasing before it became popular, the cocaine. He was lacing his cigarettes with it, though, rather than smoking it directly like they do now. And he got caught, he confessed to it all, but he still got like 4 months in the county jail. We wanted him in the county jail because if we put him in the pen, he would have only spent maybe 30 days because of overcrowding. You know, who would you rather have in jail, a serial murderer rapist or a crime lab tech who's a dope addict? So we wanted to make sure he spent some time. He had to pay back the laboratory for the $400 worth of cocaine standards that he consumed. In fact, I don't know if many of you know Brad Tellier, who's the lab director of the Portland lab. I took over his job down in Medford when he became the lab director in Portland, and he calls me up about a month after this incident and says, "Gary," he says, "do you have any cocaine standard?" He said, "Snyder smoked all of ours." I said, "Yeah, I think I got some." Of course, right away, you know, I don't know if any of you guys have large quantities of dope standards in your labs, but we got rid of ours. Anything, we do not keep quantities over a gram, quote unquote, usable quantities. And if we do, we have to inventory it, and I sure don't like inventory, so I get rid of anything over a gram. I consume it in analysis. Anyway, the point being, you know, this guy, he was a very good criminalist, actually. He was pretty smart, even though we didn't get along personally. And one of the things that was difficult for us to detect, those of us who worked with him and didn't see it coming, it developed over a year's period of time. He was up to 2 grams of freebase a day. That's a lot. Really it is. He became addicted very quickly, having all the dope he wanted, and of course being able to freebase it. Of course, you know, we freebase it anyway to run it on the IRs. Of course, now we got mass specs and things like that too. Anyway, I mentioned this to high school kids and college kids. You know, this is how dope can affect you. This was presented at the ASCLD meeting that year, 7 years ago, by our lab director, state director. And after his talk, about 3 lab directors from around the country came up to him and said, I was really appreciative of you giving that presentation because we think we've got a problem in our laboratory too. And don't be surprised if your laboratories don't have problems like that. Back to Bloodspatter. Anyway, what we can see here, a preponderance of aerosol, minute blood stains. Sure, we get the big ones. They converge in the air and they get there. But you could go into a crime scene like that and you could say somebody's been shot there. I mean, besides the bullet hole in the wall. Or the body. Definitely you can say that that's a high velocity or a high energy impact, and you can say it's a gunshot. And if you had several of those, of course, you can bring it together in a sequence of events, which I have cases of. This was a case out of the Medford area before I got down there. This was a female who had been shot through the head. You can see the hair. Went into a wall. And the rifle was a 38-55, one of these old Kit Carson type rifles with cartridges that are about 4 inches long. Went through her head. See the preponderance of the minute aerosol type blood stains. Even as we close in on it and enlarge it, you can see that there are spots that go smaller and smaller yet that in comparison with the hair width, that it is very minute and it's not recreated. Ignoring the bullet hole, you know, in case the bullet were to stay in the skull and this was backspatter, this would tell you. We've had about 4 cases in Oregon where we've successfully prosecuted homicides without the bodies. These types of situations help, especially if you've got brain tissue. That helps a lot. Medium velocity or medium energy impact, there's some pretty small blood stains there, but you don't have the preponderance of them, and also you don't have that aerosol. See if I can go back, kind of look at that. You go back to you don't have that misting like you do with firearms. This would be like a blow with a bludgeoning device, baseball bat, pipe, or whatever. That was created, and we can do this in our experiments today, created with a rat trap. So even the impact, high energy, what you would perceive as high energy impact of a rat trap coming down on a bloody sponge does not produce the same type of high energy impact bloodstains, the aerosol effect, that a rifle does, or any other firearm. And my experimental chair that gets beaten numerous times, one of the things that can be told by bloodstain interpretation, of course, is the number of times that an individual may have been hit, or the number of times they may have been shot, etc. In this particular case, it's a bludgeoning. The sponge was bludgeoned with a baseball bat. And what I have actually seen in crime scenes, and of course the literature shows it too, is you will have cast off from the bludgeoning device. It gets onto the weapon, and as the person is swinging back up or swinging down, you may get a track of the blood stains as the blood is coming off through centrifugal force. Now remember, it takes at least one strike, one hit, to open a wound. You have to have blood for it to get onto the weapon. Of course, we had our blood exposed focused on the sponge previously. But at a crime scene, you can see these tracks. You can count the number of ones. Even if you concentrate on trying to get the same track, it's very difficult to follow the same path and duplicate the same path. So you can usually count fairly accurately the number of times a person's been beaten. And this actually does show up at crime scenes. I was surprised. I thought this was something that could only be done on an experimental basis. Yeah, it sounds good. Yeah, you can create it, but does it really happen in the real world? And it does occasionally. And this is where you're able to determine, in one case I had, that the person was using his right hand to swing the weapon. The situation was that we had two Indians this was in Washington State, in the Goldendale area. Two Indians attacked two other Indians that were in a bed, and they used an axe, and came down and struck the individuals and left a cast off on the ceiling, and there was also a wall here. And the situation was interesting because both suspects, there were two of them, one was left-handed and the other one was right-handed. I couldn't say conclusively that the right-handed person did the axing. I mean, it's technically possible that a left-handed person could create that pattern, or if by holding it with two hands, they can create that pattern. But as it turned out, through other things, we were able to show that, yes, the person that was right-handed was the one that swung the axe. The other guy said it was, so it must have been true. He spoke first. That was an interesting case, too. We had two juries sitting on either side of the courtroom. They were prosecuting both these guys at the same time. But yet, when one lawyer would want a conference or vice versa, you may have one jury leaving and the other one staying, or they may both leave. And it was kind of interesting. This was probably the worst testimony case that I'd ever given on anything in my life. It was an interesting case, true enough, but the problem was that the temperature was like 110 degrees outside. The air conditioning had broken down in the courtroom. It was like 95 degrees in there. It was 2 o'clock in the afternoon, of course, with juries going up and down, and two sets of attorneys sending people back and forth and arguing. I knew that I had lost them within 2 minutes, kind of like you guys this morning. But, it's one of those things where you just do what you have to do, you eat it, and you move on. And both of them were convicted. So anyway, that's what we're doing with the chair there, is showing that. And that shows up on the ceiling as well. These are some other experiments that were done in the bathroom of our Portland laboratory. The janitors sure liked me. A bludgeoning near a vertical surface, or a wall. And you can see the little electric outlet there. Now we talked about stringing scenes, and I do like to string scenes on occasion. By stringing some of these patterns on a wall, you get the effect of gravity, and I call this kind of a Christmas tree effect. In other words, you have blood, even though the origin may be just about 9 or 10 inches above the floor. If you were to string the blood droplets as they lay, you can see that some are coming up and then they're not striking until they're coming down, so you get some that are almost straight up and down, so you get that kind of a half of a Christmas tree effect. What purpose it can serve, though, is it'll show what the minimum height was. In other words, you're not going to have blood spatters like these. They're nearly horizontal. They are not going to originate from somebody getting beaten up here, standing up, and then swing down and come over to the side. Unless you have high velocity winds, which I have had occasions where in an old blimp base up near Tillamook, I gave a workshop, and the only place they'd let me do it was like these old barracks that were buildings that they used to keep the blimps in, and there was like a 30-mile-an-hour rainy wind that day, and when we were bludgeoning, these blood spatters were going everywhere. So I don't usually string walls. You still can, however, do your 3 dimensions with these. Not only do you get a directionality, understanding that the lowest portion is going to give you at least where the lowest bludgeoning was or shot, but you can also determine the angles on those on a wall, and you can come out in the 3rd dimension from that wall. It's like taking the height and putting it out from the wall. You can tell how far from the wall to the 3rd dimension that origin was. Some kind of a misinterpretation can be had by kind of an optical illusion by looking at corners. This is what I call an innie. You have belly buttons that are innies and outies. This is an innie corner. And if you look at that initially, it looks like there's 2 different origins. One's coming from the left and the other one's coming from the right. But if you were to measure, do the angle determinations on those blood spatters, you would find that they do originate, in this case, 4 feet from that corner. It's just the perception of them coming from different sides because of the corner. I know it was 4 feet because I made it. But that's how it also would calculate out to. So it is basically 1 origin, but the perception here is that there's 2. With outies, the outie corner, it's a little bit easier to perceive. There it looks like they're coming from 1 origin. But you could also misinterpret it to the effect that if you did have 2 origins there and you didn't measure it out, you might miss that 2nd origin or that 2nd beating or that 2nd shot. So it is important that you take some of these and do some actual calculations and measurements. And there's the innie and the outie together in the bathroom. Of course, all this was before we had AIDS. I don't know how many times I got this stuff all over my face, rolled in it, kind of like that stuff. Of course, now with our experiments that we do now, we use animal blood. I guess you could get anthrax or something like that, but you're not probably going to get AIDS. It's not monkey blood. We used to get human blood from the Red Cross, outdated blood, but they not only would they not give it to us, but we didn't want it anyway. Anybody used to pipette blood with the mouth? Well, me neither. Never got any in my mouth either. Okay, here's a bludgeoning with a hammer. We'll take a break in about 10 minutes. Interesting thing about this is notice the directionality, the preponderance of blood is coming back in the direction of the beater, and that's due to the nature of the hammerhead. As it comes down, it's squirting the blood back in the direction of the beater, and it's generally towards her. If she was standing up and hitting something fairly high, it would tend to go away from her. And this is actually shown up in at least one case that I know of, where a foster kid hit his foster mother with a hammer numerous times. And this is one where they thought they had a gunshot. And the lab went in there and said, no, this is a beating. And later we found the hammer and did the autopsy and everything else. But when we got the suspect's clothing, one of the questions the defense attorney had was, why is there no blood on my suspect's clothing if he beat her so many times? And experiments that we did in the laboratory showed that, as it turns out, she was being beaten as she was standing up. And when we did it, we only got like 2 drops of blood on us after about 11 times the beating. So we tend to think that it's going away from the beater. Notice the star pattern, or the pattern of 6 or 7 little droplets there beyond. That, again, is another artifact of the experiment, and it can show up at crime scenes too, where you're getting blood on the hammer, and as the person holding the hammer comes up, these are blood droplets that are lobbing off and just coming straight down. So those are just low energy or low velocity blood droplets that have lopped off the hammer as part of what she's doing there. This was a simulation, or an attempt at a simulation of somebody getting their head smashed against the wall. It's amazing what some coroners and medical examiners will say to interpret bloodstain patterns with little or no, generally no, training or knowledge of bloodstain interpretation. And you come up with sneezed blood and cough blood and things like that, expectorated blood. We'll talk a little about that later too. But what we have is, I took a bloody sponge and smacked it against the wall to simulate somebody's head getting smashed against the wall. And this streak right here is 10 inches long. Now, you try to calculate that out using that formula, you get less than about a 1 degree angle. That's an excellent directionality blood streak there if you were to want to do directionality. It's almost hard to see where the head and the tail is. Julie Hinckley in one of our in our Portland lab doing some projected blood. Let's talk a little bit about expectorated blood. I don't think I have any slides of that. You can get cough blood or expectorated blood from gunshots to the chest area or to the neck or someplace where you can get air coming out. And what generally happens is you get a pattern very similar to the one up above. In fact, you can get some fairly high velocity looking blood spatters from a cough. I think somewhere I read that a cough can be projected at about 200 miles per hour. I don't know what that calculates out per second, but that's very high velocity. One of the things to help interpret these cough stain patterns, though, is not only the scene in total, including your autopsy and everything else, but we're able to do amylase tests for saliva, and that does show up in the tests on expectorated blood. I know Jim's done some, and we've had several occasions where we've had expectorated blood, and it can be misinterpreted as a bludgeoning origin or a gunshot origin. It can be confusing. Here we're doing some horizontal motion. We've got Beth Carpenter there running with the blood and doing some of the interpretations. Where this would come in of value, if you've got somebody bleeding, walking away from the crime scene or running away, or perhaps carrying an object that's dripping blood. The one within the circle there was at a walking speed. You can easily tell the directionality because you see the secondary satellite patterns coming out away from the direction of, or in the direction of the rate of travel. This is on butcher paper. If it was on cement, of course, it would break up that surface tension even more, and you'd even get greater secondary scatter. The other one, about a 30-degree angle there, is from running speed. Some of the tests that we've done using pipettes, to simulate a dripping weapon. One of the misconceptions is if you have a swinging object, where would you expect the longer blood droplets to be? To the outside or to the inside? And most people, not you of course, most people would interpret the longer blood stains to be out to the outside of the swinging arc, because they expect the velocity to be higher, but that's incorrect. Most of the angular blood stains, the 10 and 20 degree angles, are at the bottom of the swing as it's swinging across the object. And what's happening is you get a lobbing off of the others as it reaches the maximum of its arc and comes down. I think at this point, why don't we take our, what is it, a 20-minute break or 25-minute break? And
Please go.
all right, douse those lights. You can go back to sleep. Cool. Okay, this You might notice, might as well use this, see the little trailing dots that occur just before the drops of blood. I found out that this was a phenomenon of, I don't know what this is called, I'm sure there's some name, but it's just secondary. Sometimes you get up to 3 of these little droplets form off the end of a pipette when you're doing laboratory experiments, and I imagine this could also show up at regular crime scenes. And again, the point being that make sure that you perhaps understand what could cause droplets. And you're not going to be able to explain every drop of blood that exists in your crime scene anyway. Here again, just showing the directionality. The origin of this drop was from the right side, going to the left. And you can see the breakup in the secondary satellites that come off of the blood droplet. These also originate from the main droplet. They could possibly be mistaken as in some other area as perhaps a secondary origin. Now one of the things that I found is these things go up to 4 feet sometimes, especially if you've got blood dripping in blood. It'll fountain or it'll spread out as far as 4 feet. A diagrammatic view. Okay, here's what blood looks like dripping into blood. And you may get this at crime scenes where you've got an individual that may have been shot in a chair or something like that. Maintains his position as he drips blood, dripping in the same location. One of the characteristics of this is right next to elongated blood spatters, you may have like a 90-degree blood spatter. And I had one occasion in Oregon where they interpreted it as the guy getting shot standing up, which gave the 90 and 80-degree blood spatters, and then he got a coup de grace, a second shot, as he was laying on the floor, which gave the 20 and 10-degree angles. And what happens is basically you're just getting a fountain effect. Blood drips in, you get some that squirt right out to the side, giving you the 10-degree and 20-degree angles. Others are going up in the air, arcing and falling straight down right next to one of those others. So you get a multitude of directionality in those blood stains. Where it can be really confusing, if this was a carpeted floor and you were only being able to interpret what's on the wall, you might consider this as a bludgeoning or some other, maybe even perhaps a gunshot type of blood pattern. One thing I did not mention in the high velocity blood spatter and the gunshots is that aerosol effect, very fine blood spatters, generally only go a couple of feet. They may go as far as 4 feet. But at some point, because they lack the mass, they do not carry very far. So consequently, this could theoretically be a gunshot type pattern. It's just that if the origin was over 3 or 4 feet from that wall, the small aerosol stuff falls to the carpeting or to the floor, and this is all that remains of the high velocity impact. So size is not necessarily conducive of the type of impact. And of course, we're always looking for patterns like blood. One of the things that is important and that we'll show, one of the experiments we'll do today is drying time on blood, which is not generally addressed in most workshops of this nature. They do a lot of angle determinations, and they throw things in fans, and they shoot them, and they beat them, and things like that. But there is a lot of value in examining and studying the drying times of blood. One of the cases that Jim Peck's worked on in the Grants Pass area was a pizza parlor homicide of the pizza owner, and we had a shoe print at the crime scene, and we were able to tie that in with the suspect. But the suspect said that he had left for a period of about a half an hour, and that during that time is when the homicide must have taken place. And by examining the drying time of blood, we were able to, Jim and Mike Hurley were able to put the suspect at the scene within 2 minutes of the shedding of the blood. And actually, they were being generous. They were able to put him actually within 1 minute. And it's by the characteristics that are shown of the rings that begin to form within about 30 seconds of blood striking a surface. And then once that's stepped on and the rest of the blood removed, you can get different thicknesses of this ring up until a complete ring, of course, when it's totally dry. And so we'll be examining blood being spattered over a shoe print at various times. One spattering at about the same time as the shoe print's created. One creating the shoe print, letting it dry, and then spattering over that, and then creating the spatter and putting a shoe print over that. And it's very interesting what comes out of that type of thing. It's very difficult to tell. This is generally where I break. I guess I could have gone on these slides before we did take our break. This is just a curious thing. It has very little to do with blood spatter. This was a suicide helmet that was created by a 17-year-old boy. And what it consists of is melted plastic, and I'm not sure what he put it over, a hard hat or something like that to form it. And what he's got in here is 9 12-gauge shotgun shells that are embedded in the plastic. He's got rubber bands over top of nails that when he pulls this bloody cord, it wasn't bloody before, theoretically, all of these nails will come down, plunge into the primers of the shotgun shells, and they all go off at once. It worked. In fact, he had called his mom into the room and said, "Bye, Mom," pulls the cord, and they all went off into his head. Very interesting, the amount of effort that somebody would put into killing themselves. I've always just threatened to kill myself and make it look like a homicide to make it difficult for the investigators. Okay, we need to change that carousel. Any questions up to now? Appreciate those who are keeping quiet if you disagree. Actually, I'd like the input later. Somebody was asking if there were any workshops that are put on in this area. I'm not sure if there are down here in Southern California or Northern California for that matter. I've heard that Herb McDonald does give a class every once in a while. I've seen flyers. Jim Pex and I have done some. We could do it on a request basis if anybody's interested. Perhaps the crime labs aren't, but maybe if you hear of other investigators, that may be something that could be set up. Yeah?
You string for your point of origin. Do you always do the measurements, or do you just kind of eyeball it, see?
I do measurements, at least for portions of it. I don't measure every droplet. I use measurements as a backup, really kind of for my estimates. But yes, I do the measurements. And stringing a scene is really not important. All that does is give a visual effect to a jury or a judge or to the investigators as to what you're doing. And you'll see some scenes that I've strung out. But really, once you've made your determination, stringing it is just kind of icing on the cake. It's more for razzle-dazzle. You could use mannequins to simulate your points of origin or your victims. You'll see the different progressions of origins that I came up with. Some of them were rather crude, to say the least. Okay, you need to start with number 1 for
0 through 11.
yeah. I don't know what purpose this serves. We got a blood spatter on the side of a car. I suppose you could, besides the typing, you could say that maybe the car hit the pedestrian instead of the jogger running into the parked car. Had to be jogging pretty fast. This was a case that I had out of the Portland area where two 16-year-old identical twins were involved. The one was trying to study for a psychology test the next day. In fact, it was about family problems. And the other one was trying to play with him, or at least giving him a bad time. So the kid that was studying went and got a shotgun and shot his brother in the chest. And the origin was up against the wall there, and that was one of my techniques for identifying the origins, was a tennis ball and stringing it out, attaching strings to pins that are stuck in the tennis ball. What was curious, on the wall we had a handprint, and what had happened is after the kid had shot his identical twin brother, he picked him up, cradled him in his arms, held him to his chest, got blood on his hands, and then when he got up, he slammed his hand against the wall and slid down. He was so upset by it all. Rather an emotional photograph there once you know what made it. You can see the cast off blood off the end of his fingers. Now he slid down. This is one that I was expecting an oil well out of, but now it's probably burned up in Kuwait. This was an American girl that had been dating a Kuwaiti male student at Portland State, and after he graduated, he wanted to go back home, didn't really want anything to do with her. She wanted to get married, so they went out for a car ride. She pulled out a .357 Magnum and said she was going to commit suicide. This is his story. And so they talked, and he talked her out of shooting herself, and then when they start driving back into town, he says that he heard this loud noise in his right ear, and she had shot herself in the face. And there's the trajectory there, showing the entrance just above the left upper lip and exiting out the top of the left ear area. One of the things that helped substantiate his story, as it turned out, was the blood spatter on her hands, indicating characteristics of her hand holding a firearm and getting blood spatter across the fingers, especially the trigger finger here, her thumb having to hold the .357 in such a manner that it allowed for a 90-degree angle spot on the thumb, and yet with the arcing of the thumb, it gave a streak there. Anyway, it was consistent. This was the car, my tennis ball. I get a lot of questions. How did you get that tennis ball to hang from the air like that? I use black thread. It doesn't show up quite so much. Suspend that. I now use, rather than using regular string, I use elastic string that you can get at any of the fabric shops. And what that does, the elastic stretches so you don't get this ripple effect or sagging when you're stringing these things. It makes a better strung seam. And the problem, though, is when you're using elastic string, it tends to pull the ball in another direction. So not only do I have a black thread holding it this way, but I also have to have a black thread pulling it from the other direction to my area of origin once I've determined in 3 dimensions, wherever the spatters are, where that origin is. And a tennis ball is, for most scenes, as far as the spatter goes, it's generally about the error factor that you're looking at for origin. And in most cases, if you can get that tight, that's good enough for the case. And there are some cases where you could get even tighter as far as if it was that critical to be within a half an inch of a certain location, it could be done in some cases. This is just a view from the other direction, showing that it was consistent with her being shot, with her sitting in the chair, and of course the spatter on the hand, the powder pattern that was on her face. I could have taken one from above, but I didn't think of it until later that there was a sunroof there too that I could have taken a photo from above. Anyway, the guy did get off. We believed his story that she had shot herself. This is another suicide located in a vehicle. Here you can see the spattering on the hand and hands, and it was all consistent with this individual shooting himself. There was a little bit of a problem because the investigators that went out to the scene said at the back of the van there was a pool of blood and dripped out on the ground. And after further investigation, once they got into the van, they could see that this guy had bled out, and it was on a slight hill, and the blood had run back to the back of the van and dripped down onto the ground below. It seems very simple to us that have worked in crime scenes, especially working with blood patterns and things like that, to overlook what investigators perceive as real problems. Talking about the secondary spatters I mentioned on the SWAT team one, where you just simply had dripped blood, but because of a little bit of knowledge, they saw the secondary satellites and felt that it was some other source. Nice back spatter all over the gun, of course. Nice that it's still in his hand. Once we removed the hand from the gun, of course, there was an area, a shadowing, where there was no blood spatter, of course, as opposed to somebody placing the gun in his hand. It all fit in quite nicely. This is another one I had in Grants Pass area. Two bums working, or living in a lumber yard near railroad tracks. The only problem is our victim, who associated with this guy, this guy that did the beating, he's a pretty nice guy, except when he got drunk, like so many of us. You know? I just get goofy. I don't get belligerent. This guy got belligerent, and he grabbed, well, I was going to say a 2x4. It was a 2x6, but then by the time he got done, it was like a 2x4. And you can see the blood spatter coming from the end of the 2x4, the piece of wood, and yet the force was so great when he swung down, the blood stains themselves streaked just from the force of him coming down. So you get a side action of the centrifugal force, or the board coming down, streaking the wet blood. Of course, there's hair all over it. Close up there. A variety of patterns. That's it. Any more questions? We'll get into some more questions. Yes.
On that particular slide, the perpendicular marks that were attributed to the movement of the board, were those caused by centrifugal force, or would there be some wind component to it?
It'd be the wind, actually. It's not the centrifugal force. Yeah. Okay, this is one, teenagers playing with a gun. They had a sawed-off 20-gauge shotgun. In fact, it might have been the same one that I used in that enclosed indoor firing range I mentioned earlier. Anyway, they came to the scene, saw this guy dead, obviously. Pattern on the wall they interpreted as high-velocity blood spatter. He shot in the chest area. They felt that this guy had been shot while he was laying on the ground. The story that the suspect gives is that they were playing with the shotgun, smoking dope, and they'd point the gun at each other and pull the trigger. Well, little known to our suspect, this particular bolt-action shotgun, the mere action of lifting the bolt and putting it down, not even sliding it back, would cock the weapon. And of course, they didn't know it was loaded, according to this guy. And he apparently had worked the action up, lifted the bolt up and put it back down. And the next time he shot into his friend's chest. And so they said they were in another part of the room and that this guy had walked over to this location. But when we got to the scene, we looked at the pattern that was on the wall, looked at the wound. He was shot in the aorta. And in fact, when he was telling the investigators, he tried to help the kid. He was bleeding so heavily, it was squirting out. He tried to put his hand over the wound and it would squirt out. So what you have here is the product of arterial bleeding. I mean, he still was shot, but he was not shot as he was lying down, or at least there was no indication of that. It's not high velocity. Any of that is not high velocity. Another aspect of this, when the investigators were at the scene, there was another bedroom next to this that was used for a marijuana grow operation, and there was about 30 plants about 5 to 6 feet high in there. And what happened is when we all left, nobody left, secured the scene. They went to get a search warrant to get the marijuana plants, and when they come back, all the marijuana plants were gone. Can't understand that. It must have been a figment of our imagination. Okay, here's some expectorated blood. This guy was shot in the chest near a sliding glass window. And some of the characteristics of this is very small. These are less than 1/16 of an inch in diameter. These could technically qualify as high velocity or high energy impact blood spatters. One of the characteristics you'll see, it's somewhat runny, dilute in nature. And we also were able to test positive for amylase. But this guy, though he was shot in the chest elsewhere, had expectorated, coughed up this blood onto this window in an attempt to try to leave the scene, but died. But it could be interpreted, because it was so small, as a gunshot area, and it would not have fit our scene. This is another one. This guy had been in a fight and had gone back to his $10 a month trailer that he was staying in and died in his bed. When they got to the scene, they looked at this. There was blood spatter for up to 8 feet away from his mouth, and they thought he had been beaten, but we could find no way that any of this was consistent with a beating. And what we had here was, he had lived for some time and had coughed blood out onto the sheets and onto his hand. And like I said, that went up to 8 feet away. This was an attorney who killed herself. Of course, they were suspicious. Again, another coup de grace, perhaps near the floor. 22, she put to her chin, went through her head while she was standing up. She apparently had lived and rolled around a little bit for a while and had coughed blood onto the door jamb area here. And again, it has the appearance of high velocity, or at least medium velocity blood patterns. And again, tested positive for amylase. Very sensitive test. Every serologist do it. I don't do it myself. I'm not a serologist. Hocus pocus anyway. I don't understand it, that's why. This is another one. This guy had been beaten, and in this particular case, he had laid there for some hours before he died, coughing blood. This blood is mixed with bile. It has a dark appearance to it, much more darker than you would expect from just age. But coughed all over the place, basically. You can see how fine it gets. Just cough basically right up in the air and comes back down. See on his hands where the cuff had protected it. And we had coughed blood from his mouth. It's about 8 or 9 feet to this area over here where we had coughed blood, so it can travel quite a distance. But it was a homicide. He had been beaten. He just had laid there for some time. This is one that happened in the Roseburg area. Ex-wife comes home from a day at the beach with her 13-year-old son and her new boyfriend. The ex-husband is laying in wait at the apartment. She walks in, he plugs her twice near the bed. The boyfriend goes running out, and he gets shot as he's backing away from our suspect. Gets a nice pattern on his face. And where that originated from was from his arm. He had his arm up, and the bullet traveled through his arm, causing that pattern on his face. And what they're doing there with the little swivel stick, the cotton swab, is showing the area where the wound was, where his hand was when the blood spatter got onto his face. It's not a tennis ball, but it works. Kind of hard to see though with the white gloves. This is where he had shot the woman at one time and went through her. Bullet ended up in the bathroom tile. High velocity blood spatter here and here. And then she crawled into the next room and got it again when she was laying on the ground, on the floor. Drip, drip, dripping blood. Here's the note he left. It's probably hard for you to see, so I'll read it to you, because it's hard for me to see too. This is just part of a 4-page letter that he left her on a card. When you care enough to send the very best. Hallmark. This page starts, getting up at 3:30 in the morning to go to work. Get back at 6:30, 7 o'clock at night so you could whore around on me. Fake meetings at night, gone to parties while me and the boys were hunting, taking someone else to work and back, stealing money out of our checking account. It's over now, slut. See you in hell, bitch. So, very emotional, upset sort of guy. However, he was repentant. This is him. He took that .30-30 rifle, stuck it under his chin, and took off his chin and his upper mustache. Here they're working on him, still alive. There he is, minus the chin, and a few teeth. There were teeth and bits of mustache all over the apartment. He actually lived for about a week, and then just as they thought he was getting better, he died. So, and that saved us a lot of work. We kind of held off while he was holding on. Sometimes it pays. Now, one of the questions I usually ask the investigators or police officers I give this class to is what kind of weapon probably killed this person? And I don't want any jokes about a pair of 44s. That's what I'm saying. Basically what this is from a .30-30 rifle, and the way this, usually they say a shotgun. This is what it looked like, minus the sweater. This is done with a .30-30 rifle. We have an entrance here, and actually the jacket was found in here. There was an intermediate object that was between her and the barrel of the rifle. That's what it was, her hand. She had her hand, her thumb area over the end of the .30-30 rifle, and it blew the thumb clean off, as Clint Eastwood would say. This is the bathroom. She was found in the bedroom on the floor. He claimed that, yeah, they were having an argument. He grabs the gun and just is pointing it to her, and it accidentally went off. And that's where she was found, was in the bedroom. But we showed that this occurred in the bathroom. The slug was separated from the jacket after striking her hand, which about 50%, as you know, about 50% of the time, you've got a jacket around. Once it strikes an object, it's not uncommon for the jacket to separate from the core of the bullet. The jacket stayed in her, and the core went on into the wall and dropped down about 3 stories. We never did recover that. We didn't really care. But we had an outline from her exploding hand from the gases coming out from the end of the rifle that left a nice outline of her body crouched in this corner. And I think I've got a little better picture of that. Even though this is underexposed, it shows a little better the pattern that was created from her. So we showed that she was in this room, and she probably had her hand over the end of the barrel. I mean, there was powder burns on it and everything. Trajectory doesn't mean a heck of a lot once it passes through the body. Close up of the high velocity spatter. Okay, she actually lived for a short while. Before I get to that, though, we were able to show blood spatter in the bowl of the toilet, this marking the highest point. Of course, you are going to get a shadow effect from the lid of the toilet. In other words, at some point, the blood coming straight down is not going to be able to curl up underneath the lid. So even without angles, if you get something that will give you shadows like the edges of tables or something like that, you can just take a straight edge and make trajectory determinations. This is a good point why you don't let the investigators use the toilet until the crime lab gets a chance to get there and do these interpretations. And then it's okay for us to. But we were able to show that her thumb, at any rate, when it exploded, when it got shot, was 17 inches from this wall and 13 inches from this wall. And considering her structure, her dimensions, whatever, she was probably being pressed up against that one wall pretty tightly when he pulled the trigger. And after he came up with about 20 stories, we told him what actually happened, and he was convicted. Here's a private eye. So far we've had an attorney, now we have a private eye. Incidentally, is there anybody that's had any relatives or friends murdered in Oregon? I need to ask that these days. This one I was showing to a group of police officers in the Medford area, and this turned out to be one of the police officer's ex-boyfriends. And she said, she came up to me later and she said, well, that was my ex-boyfriend for a long time. I always wondered what happened to him. So, well, there he is. You want a copy of the picture? Anyway, got a hole in the top of his head, 12-gauge shotgun shell with 12 double-aught buck shells in his neck, as it turns out, sitting in a chair. Ex-girlfriend, or girlfriend rather, live-in girlfriend, they're having a fight. She claims that he started to get out of the chair to grab the rifle and shoot her. Of course, that's why the shotgun to the top of the head, and that he fell back and died. Oops, there we go. Various blood spatters on various objects, such as walls and Venetian blinds. You have to take into account too a little bit of curving from the blind. It still shows good directionality though. Showed the area of impact was pretty much where he was seated. And these things go out as far as 12 feet. Some of them were fairly large. Here again, they're not the minute aerosol blood spatters, but they are still considered high energy or high velocity blood spatter. Plus we had blood stains on the side of his shoe. It's very difficult if a person's getting out of a chair for the blood to come around and hit the side of the shoe, even if the cuffs don't cover it. Besides that, his legs are crossed, and most people don't get out of a chair with their legs crossed. You can, but it's difficult. You probably didn't do it. So pretty much we probably had this guy sitting about where he was when she plugged him in his sleep. And it looks like his head may have even tilted over to the other side from the energy of the impact. And then as he bled out, it dripped back again because you can see an area where the blood dripped down the side of his face and there. And then the head, after losing some blood or whatever, flopped back to the original position. She was found not guilty by reason of insanity. That has since changed, of course. In most states now, you can still be insane but guilty. And that's probably what she did. Doesn't pay to be a private detective. This was a case out of Yakima, Washington. they came down, they had a taxi cab driver that had been shot through the eye and out the back of his head with a .38 revolver. The suspect was claiming that they were outside of the cab when the cab driver was attacking him. He was going to steal his money or whatever. And so in self-defense, he pulls out the .38 revolver and shoots once through the eye. The cab driver, having had half his head blown off, was shot through the eye and out the back of his head, gets back into his cab and drives away from the scene before he dies, which was pretty ludicrous to the investigators. So they brought this down. They felt that the cab driver had been executed or killed inside of his cab. And they brought the door down to prove it. So they showed this to me, brought the door down, wanted me to say, do all the interpretations just based on the door and the bloodstains there. I told them I couldn't do that. I'd have to look at the vehicle with the door back on it at the scene. Notice that the window is down about 6 inches. That becomes important later. This was the scene. This happened about 3 weeks after Mount St. Helens had erupted. One of their concerns was as if this guy's story was right, that he shot the cab driver while they were outside, where's the blood that should have been located on the ground? Well, considering there was all this ash all over the place, and about a dozen investigators and supervisors drove through the scene, it didn't really bother me that much that there wasn't any blood in that location. But he had apparently parked here. This is where the incident occurred. Shot the guy. The guy gets back into his car, according to the suspect. Throws it into reverse, drives backwards down this road, does a backwards reverse U-turn, or tries to, pulls in behind these cars, pulls in here, and then apparently died running over these bushes and bouncing around, coming to rest next to this building. Of course, this was a week after the incident, before I even got up there. Remember, I'm only telling you the ones that I did good at. Here's a diagrammatic view showing where the incident took place. The guy apparently gets back into the car, throws it in reverse, drives backward down the road, and comes to rest to this side of the building, or back here if you can see behind the screen. Okay, 5 hours later, or $10 later, we get the door back onto the cab. We look at the blood spatter on the door, inside of the car. We find no blood spatter on the door or in the car that is consistent with a gunshot type of blood spatter, particularly if it's going into a head, hitting through the eye, coming out the back of the head. We had no bullets in the car, so we're wondering, well, maybe this did take place outside. Maybe the kid's story is true. Close up, even though you got some fine stuff there, it's not consistent with gunshot. After looking at most of the day in the inside of the vehicle and talking to the DA saying we can't disprove this kid's story, we started looking on the outside of the car, and we began to find minute blood stains on the vehicle itself on the outside. This is the hood of the car. Now, this spot here you see is just a letter that I wrote in there for reference. The actual stain is right there. Very small, considering the size of the string here. Relatively narrow string. We were also able to show from blood spatters at certain angles, in conjunction with those on the hood of the car, that the door was open slightly in this position when the gunshot took place. And it wasn't from blood spatter. There was no blood spatter on the inside. That would have been easy, obviously. That would have exposed the door, and therefore he could have gotten blood on it. But it wasn't from that. It was from the angles that we measured on the outside of the door and positioning him outside. A futile attempt at making poor old Larry getting shot through the eye. He actually was shot outside of the car. Probably could have cleaned up my debris a little better to make it look better, or brought a mannequin in would have helped also. But we showed the origin with the blood stains on the roof and on the hood of the car that I showed you, that the origin was approximately, give or take 6 or 7 inches, 66 inches above the ground. This guy was 6'2". Larry getting shot through the eye. He gets back into his car apparently and drives backward down the road. Now, one of the things that we did, even though this happened a week later, I investigated it a week later. You're familiar with gunpowder patterns. The powder comes out the end of the gun. Well, what we did was we vacuumed areas of the outside of the vehicle where we might find gunpowder if, in fact, we had been shot outside. In addition, we vacuumed the interior of the vehicle as well. It so happens that the kid had shot twice. There were 2 empty rounds in the revolver, and there was 5 Spear brand type of ammunition and 1 Norma brand. And 1 Norma and 1 Spear brand had been shot. And the investigators, when they removed the cartridges from the cylinder, marked down which chamber each casing came from. So we were able to show a sequence of firing. It turns out that on the outside of the vehicle, these are unfired. These are just for explanation. But this was I believe this was the Norma brand. We know that it was the first shot because the investigators in the sequence of the firing had marked down which cylinder chamber it came from. We found partially burned and some unburned powder particles on the outside of the vehicle that showed that that first shot from the blood spatter that went through his eye, had only been shot once, did in fact take place on the outside of the vehicle. When we vacuumed the inside of the vehicle, we found another type that was consistent with the Spear brand of ammunition inside of the vehicle. Another diagram. So here's Larry, the cab driver, and he did have a reputation for ripping off his clients. If they were drunk, he'd take their money or their watches and stuff like that. 6'2" Larry, getting shot through the eye, bullet exits out the back of the head, not recovered. We found no bullet holes anywhere when it was on neighbor's yard. He does get back into the car, apparently. That's where he was found. Remember, the window was rolled down about 6 inches. We found ammunition from the second shot inside of the vehicle, and apparently he missed. Goes past Larry because it didn't hit him, and the bullet must have gone out the other window, which was also down 6 inches as well. We never recovered that one, so we had a second shot after he had gotten away from this guy, which kind of helped eliminate the self-defense. Why did you have to take a second shot if he was already leaving the scene and he wasn't bothering you anymore? And apparently he had enough brain activity in his head to get back into the car, throw it in reverse, and drive a short distance down the road where he did finally die. The medical examiners had a problem with that at first until I presented this information to them about the gunpowder and the blood spatter. I mean, we had the blood spatter outside of the vehicle. It's gunshot blood spatter. And they said, like so many hunting stories that you hear, you know, the deer and the elk that run for miles with an exploded heart, that given this evidence, that must have been what had happened, and who knows what the human body can do under a certain situation. That's the way the report went out, showing the diagram of the origin 66 inches above the ground in connection with the cab, and showing the relative location of where the blood spatters crisscrossed to. So here's a good example of where a case was not just made on the blood spatter, but it was vacuum sweepings, examination for the gunpowder pattern.